Hi Algebra 2, this is Unit 5, Lesson 5, and today we're going to talk about geometric series. So a geometric series is the sum of the terms of a geometric sequence. Remember, sequence is just a list of terms. So if we look here at our example, I have a list of terms, 2, 4, 8. Basically, I'm multiplying by 2 each time. And the series is the sum of those terms, so 2 plus 4 plus 8. So once again, I'm going to have a formula to do that. All right, so S of n, the sum of all the terms, equals the first term minus the first term times, oops, that should be a sub 1. Let me just fix that. Minus the first term times r to the n, and we'll go define what each of these is, over 1 minus r. Okay, so n is the number of terms. So again, we might run into a situation where I have to figure out n. A sub 1 is the first term, and r is that common ratio. Okay, this is on the reference sheet. So for the regions, this is on the reference sheet, is not a formula that you need to memorize. All right, it's on the reference sheet. Again, you take the first term minus the first term times that common ratio to the nth power over 1 minus r. So let's try it out in our first example, which is pretty basic. So find the sum of the first 7 terms, so n is 7, of the geometric series. So my first term is 1, and then the other thing I need to know is my common ratio. So I'm going to look here. All I have to do to find the common ratio is to take the second term and divide it by the first term. Or you could take the third term and divide it by the second term. But my common ratio, no matter which 2 terms you divide, is 2. So S of 7, because there's 7 terms, equals the first term, a sub 1, minus the first term, a sub 1, times that common ratio. And to the exponent is going to be n to the 7th power over 1 minus 2. Okay, and all that can just go right into my calculator. If you want to do it in your calculator, though, please remember that when you have this fraction, it's like implied parentheses are going on, so you need to put that in parentheses and the bottom in parentheses. I generally just put everything in the numerator and I hit enter, and then I divide by everything in the denominator. Okay, or I would just do the denominator actually in my head. I would do 1 minus 2. But anyway, that gives me 127. So this is the sum of the first 7 terms of that geometric series. All right, looking at 2. Which of the following represents the sum? So again, I got sum. I got a geometric series, 8 terms. So I know that n is 8. Whose first term is 3. And whose common ratio is 4. So my first term is 3, my common ratio is 4, and n is 8. All right, so let's fill it all in. Sum of all 8 terms is the first term, 3, minus the first term, 3, times the common ratio, 4, to the nth power, which is 8, over 1 minus r. And my common ratio is 4. So again, this whole thing can go right into your calculator. If you're doing it all at once in the calculator, you would need parentheses around the numerator and parentheses around the denominator. And put that all in. Practice doing that in your calculator to make sure that you're okay doing that. And you get 65,535. So choice 4. All right, just like we did with the arithmetic series, sometimes we don't have n, so that's what's going to happen in question 3. Find the value of the geometric series shown below. Show the calculations that lead to your final answer. Use the formula a sub n equals a sub 1 times r to the n minus 1 to find n. All right, so let's find n. Let me get my pen. Find n. So a sub n equals a sub 1 times r to the n minus 1. So my last term is 768. My first term is 6 times my common ratio. You can see that I am multiplying by 2 each time, all right, because this is the sum of the terms. But if I wanted to see the terms as a list, they would just be this. not to confuse you, okay? But the common ratio is 12 over 6, which is 2. So the common ratio, is 2. Let's put in 2. And to the n minus 1. All right, so I'm going to divide by 6. And 768 divided by 6 is 128 equals 2 to the n minus 1. And I can solve this either with logs, or I actually can get a common base. 2 to the 7th power is 128. All right, otherwise you could solve it with logs. And once you have a common base, you're really just setting those exponents equal to each other to solve. So 7 equals n minus 1, and n equals 8. All of that to find n. Now I can finally do the problem, which is to find the value of that geometric series, to add them all up. So the sum of all 8 terms equals the first term minus the first term times the common ratio to the nth power over 1 minus that common ratio. So this whole thing goes in your calculator, parentheses around the numerator and the denominator, and I get 1,530. Okay, so if you don't have n, you're trying to find n, a little bit more work is involved than just substituting it into our formula. This formula is on the reference sheet. All right, so here's an interesting problem. A person places 1 penny in a piggy bank on the first day of the month, 2 pennies on the second day, 4 pennies on the third day, and so on. Will this person be a millionaire at the end of a 31-day month? Just thinking about it, you're probably like, no, how could they be a millionaire? They're just putting pennies in. They are increasing it by 1 penny each day. So this is basically, all right, I have 1 penny. I'm finding the sum of the first day plus the second day plus the third day plus the fourth day. Oops, I'm sorry, I'm doubling these, and I'm not doubling them here. Okay, so first day I double it, I have 2 cents. The next third day I have 4 cents. The fourth day I have 8 cents. Dot, 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 dot. Okay, so S of 31. I'm going to add up the sum of all 31 days. Is the first day minus the first day times the common ratio. I'm doubling it, so that common ratio is 2 to the 31st power over the first day minus 2. And if I do this whole thing in my calculator, all right, I get $21,474,836.47. I know, it's unbelievable. So yes, this person is a millionaire. So if somebody ever asks you if you want to work and get $1,000 a day for a month, or you want to get a penny and double it each day, then you definitely want the penny and double it each day. All right, Maria places $500 at the beginning of each year into an account that earns 5% interest compounded annually. So we're going to be looking at some of the stuff we learned in the last unit. Maria would like to determine how much money is in her account after she has made her $500 deposit at the end of 10 years. So think back to last year. We need a formula. A sub t equals P times 1 plus R. Remember, my rate is 5%. So 1 plus 0.05 is 1.05 to the t power. Okay, so I want to figure out what it is for t number of years. I'm not going to have an actual amount of years. Okay, and determine the amount of money that 500 invested in years 1, 2, and 10 have earned. This is super tricky. Okay, she puts $500 in year 1. That's actually going to earn the most amount of interest. All right, it's earning the most amount of interest, because in year 1, that money is in there for all 10 years. So 500 times 1.05 to the 10th power, because it will be in there. The first year she puts money in, that's going to earn the most interest. The second year she puts money in, Okay, year 2, again, she's going to put in $500, but year 2, it's only going to earn interest for 9 years. So that's only going to earn $775.66. Year 3 comes, again, she's putting in $500, but that money is only going to be earning interest for 8 years. All right, just so you can see what's going on here. And what I really want you to see is $500 she puts in year 10 is only earning interest for that 10th year. Okay, so I didn't have to do year 3. So I got year 1, year 2, and year 10 is only earning interest for 1 year. So that's only going to get $525. So these are the 3 things that the question asked me to find. Evaluate this sum using a geometric sum formula. So the sum of all 11 years. Okay, so basically they're asking me for what you earned on the 10th year. Well, this is what I put in on the 10th year. Plus 5 times 1.05 to the first. This should be 500. Plus 500 times 1.05 to the second. Plus 500 times 1.05 to the third, and so on and so on and so on. But let's just use our formula. The sum of all 11, okay, because I'm putting money in on the last time that I'm putting in at the end of 10 years, I'm also going to put it in. So 500, that's the initial, minus 500, 1 plus the rate, so that's 1.05 to the 11th power, over 1 minus 1.05. So that's going to be $7,103.39. So that's the sum of all of that money if you put in $500 a year for 10 years. All right, and we will practice that.